Welcome to the presentation on the high-level design for a news aggregator system. In this presentation, we will explore the architecture, key features, and design considerations necessary for building a scalable and effective news aggregator platform. Let's dive into the details. Here's the agenda for today's presentation. We will start with the requirements and features of a news aggregator system, followed by the high-level architecture. We will then explore important aspects such as scalability and performance, security considerations, and monitoring and logging. We will also walk through an example flow of the system and conclude with a summary. Let's begin by discussing the core requirements and features of the system. A news aggregator system needs to efficiently collect articles from multiple data sources. These sources could be news APIs, RSS feeds, or web scraping. Filtering is critical as the system must categorize articles based on user preferences, such as topics or time. Furthermore, the system must deliver news in real time, ensuring users always get the latest content. Personalization is also key. The system should tailor the news experience based on the user's interests, location, and reading history. Now let's look at the various data sources that provide content to the aggregator. News can be pulled from APIs like News API or Google News, RSS feeds, and through web scraping for unstructured content. It's essential to standardize all raw data into a consistent format such as JSON, XML, or HTML to streamline processing. Next, we have the injection layer where we handle the collection of news. We can use a ETL pipeline, extract, transform, and load to gather and standardize news from different sources. Additionally, for real-time data streaming, we can utilize tools like Apache Kafka or RabbitMQ, which allow us to handle large volumes of incoming data efficiently. In terms of data storage, we need to decide on the appropriate technologies for different use cases. Relational databases like PostgreSQL or MySQL are good choices for structured data, while NoSQL databases like MongoDB or Elasticsearch are better suited for unstructured data or large-scale searches. We can also integrate a caching layer using Redis to enhance performance by reducing latency in data retrieval. Once we have injected the data, we move to news processing. This involves categorizing news articles, performing text processing for summarization, and entity extraction to identify key topics and names. Additionally, sentiment analysis can be applied to determine if an article has a positive, negative, or neutral tone. Data deduplication ensures that duplicate articles are removed, providing a cleaner user experience. A key component of the news aggregator system is the recommendation engine. Here we can use collaborative filtering to suggest articles based on the preferences of similar users. Alternatively, content-based filtering looks at the user's previous reading history to recommend similar articles. A hybrid approach which combines both techniques can offer better accuracy in personalization. After processing and recommending the content, we need to deliver the news to the user. This is where the news delivery layer comes into play. A responsive web interface built with frameworks like React or Angular ensures users can access news on desktops and mobile devices. Additionally, we can create native or cross-platform mobile apps using tools like React Native. Content can be served via APIs, either RESTful or GraphQL, providing flexibility and scalability. An important feature of news aggregators is the notification system. We can spend push notifications for real-time updates, ensuring users are informed immediately when breaking news happens. Email alerts can also be configured to deliver daily or weekly news summaries based on the user's preferences. Notifications should be tailored to match the user's interests, topics, and activity. Now let's discuss scalability and performance. As the system grows, we need to scale horizontally using load balancers to distribute traffic evenly across servers. Adopting a microservices architecture allows for independent scaling of services as needed. To handle vast amounts of data, data sharding can be applied, dividing the data into manageable chunks across different servers. Additionally, leveraging a CDN content delivery network can ensure fast content delivery worldwide. Security is a critical concern in any system. For authentication, we can use protocols like OAuth or JWT to ensure secure user login. Data privacy is essential, especially in light of regulations like GDPR. We should also implement anti-scrapping measures such as rate limiting, CAPTCHA, and IP blocking to protect our system from malicious users. Monitoring and logging play a crucial role in ensuring the system's health. We can use tools like the ELK stack, Elasticsearch, Logstash, Kibana, or Prometheus or Grafana for log in aggregation and performance monitoring. Setting up alerts for issues like injection failures or traffic spikes is essential to maintain uptime. Collecting matrices allows us to track the system's performance, such as response times, and ensure smooth operation. Let's walk through an example flow of how the news aggregator works. First, news articles are injected from various sources. Then they are processed, categorized, and stored. The recommendation engine suggests articles to users based on their preferences, and the articles are delivered through the web or mobile interface. Finally, users receive notifications for breaking news, ensuring they are always up to date. In conclusion, the news aggregator system is designed for scalability, real-time content delivery, and personalization. The architecture focuses on handling large volumes of data, ensuring that the system remains fast, reliable, and secure. The system can be expanded and adapted as needed to meet the growing demands of users. That concludes our presentation. I hope you have a better understanding of how a news aggregator system is designed. We are now open for any questions or clarifications you might have. Thank you.